Hello, I'm Xingyu, a PhD candidate from the Multimodal and Embodied Interaction Lab, CTU of Hong Kong. I'm going to present our paper, Emoband. It's a joint work of mine and my supervisor, Dr. Xingyu. We communicate emotion through multiple modalities, like facial expressions, vocal factors, or tactile sensations. Despite existing applications mainly focusing on visual and audio channels, the HCI community has studied affective haptics to deliver the missing physical sensations in remote settings. These tactile stimuli also have the potential to augment the affective expressiveness of multimedia contents, for example, enriching our interaction with virtual assistants. Existing work has studied people's emotion perception towards parameterized tactile stimuli. These stimuli are usually short and abstract, encoding affective meanings, also called tactile icons. Other scholars studied people's affective responses to the textured materials. In general, the materials with comfortable attributes tend to invoke more pleasure feelings. Building upon the two research streams, we studied people's affective perception towards tactile icons from different materials through a wrist-worn tactile display. We chose the wristband based on three rationales. First, wrist is related to emotional activations, like social touch. Second, it is sensitive to passive haptics. Last but not least, the popularity of the smartwatch makes the wrist a promising location to receive these tactile messages. We chose stroking and squeezing as our tactile motions since they can be applied directly to user skin from softer fabrics. Other formats like vibration or thermal might change the tactile sensations of the textured materials. We choose 5 common fabrics from the local market. To measure people's affective responses, we use the valence arousal rating scales. To proceed the research question, we designed Emoband, a wristband that can stroke or squeeze on users' wrists. The wristband is driven by 2 cylinders. Load cells are inserted in the device to monitor the real-time pressure of the squeezing, therefore achieving precise control of the squeezing feedback. These are the 5 natural materials in our study, which can be easily attached to and detached from Emoband. Before the main study, we did a preliminary study to test the material's physical properties and the subjects' ratings on the material's tactile sensation. 3 materials stand out. Silk is the most smooth, slippery, and soft one. Leather is also relatively smooth, slippery, but hard and cool. In contrast, wool is rough, sticky, and warm. Our study 1 investigates the affective perception of stroking stimuli with 15 subjects. We have 5 materials and 3 stroking factors. We collected the subject's valence and arousal rating for each tactile condition on a 7-point Likert scale. After the session, subjects explained their ratings through a semi-structured interview. Study 2 on squeezing feedback was conducted in a similar manner. Now, let me share the results.
Our first finding echoes the previous research that the materials causing comfortable tactile sensations tend to convey more positive meanings. For example, silk, which is mostly felt comfortable, conveyed the most positive valence. On the other hand, wool, the most uncomfortable material described by our subjects, conveyed the most negative valence.
Our second finding is that the tactile parameters would affect the emotion perception of both stroking and squeezing icons, but in different directions. So that is to say, for stroking, increasing the velocity or prolonging the duration would increase the perceived arousal and valence. But for squeezing, intensifying the pressure or prolonging the duration would increase the arousal as well, but decrease the valence. Therefore, the 2 tactile formats demonstrate different valence perception tendencies. We also noticed that the valence rating tendency of squeezing is similar to the previous study on affective vibration, visual or thermal. Looking into the qualitative feedback, we found that the subjects tend to interpret the encoded fact based on the semantic meanings of the on-skin motions. For example, the weak stroking feels calm and depressed. The intense one feels happy, outgoing, or exciting. We also present the valence arousal map of each material. On the map, each dot represents an averaged valence arousal rating across 15 subjects under certain tactile conditions. For example, CLF indicates stroking clockwise, long, and fast. One thing we found interesting is that different materials demonstrate different valence ranges. Statistically, increasing the stroking velocity would always increase the perceived valence, but would not change that for wool. When looking into this issue further, we found that the difference in the valence range was due to the between subjects difference in valence perception. Our 15 subjects formed a consistent rating on valence changing tendency, but hold varying perceptions for wool, therefore forming a V-shaped distribution. We suspected that the between subjects rating consistency might relate to materials' physical properties. Therefore, we computed the standard deviation of the 15 subjects' linear regression slope in the VA space and tested its correlation with materials' tactile sensation ratings. The results show that smoother, slipperier, and cooler materials tend to elicit more consistent valence perception than rough, sticky, and warm materials. In our case, that is leather and wool. We would like to discuss a little bit more on this finding, considering that people interpret emotional meanings only from the effect encoded in the tactile icons and the tactile sensation of the contact media. It is probably the consistency between the two clues that affect the between-subject difference on valence perception. If the material feels a match with the tactile icons, people feel similar in the emotional meanings. If the material feels contradicted with the tactile icons, there might be mixed feelings between subjects. However, this is only a hypothesis. We formulate several design considerations based on the findings. First, the VA map of different materials can be referred to design register one affective tactile icons. However, how the tactile icons pair with other modalities like emojis or text messages need further investigation. Second, different materials act differently for the manifestation of the stroking icons. As I mentioned before, the match between the material and the tactile icons might matter. Considering the individual difference in valence perception, we recommend a calibration phase for the system to learn the user's perception tendency, therefore to offer tailored effective feedback. Our work has several limitations. First, we did not address much on the context factors, like in what situation, if there's a conversation context, if the user receives the stimuli being still or walking. Also, users might not want to change their wristband from time to time. Therefore, how to change the material's texture dynamically is an interesting research direction. Besides, the current device is bulky and the studied results cannot be generalized to more materials. Addressing these issues will advance the work to real-world scenarios. Thanks for watching. For more details, please refer to our paper.